Hi guys, so in this video we're going to be learning about how we can find the area of curves that go below the x-axis. So let's say we have this curve. And as you can see, it goes below the x-axis, and let's say we're asked to find this area. Well, what we can do is we can do a similar thing to how we do an integration question where it's above the x-axis. It's like we do it the same way as if it was like this and the bounded area was up instead, it was reflected over. We do the same thing using the bounds. So let's say this is x equals 1. This is x equals -1. -1. So what we do, of course, so let's just assume this is like x squared minus 2. So we'd integrate x squared minus 2, which would give us 1/3 x cubed minus 2x plus c, but we don't need that, as we remember. Then we'd evaluate it, 1/3, and then it would be 1 cubed, because you take the higher bound, minus 2 times 1, minus 1/3 -1 cubed minus 2 times minus 1, which would give us 1/3 minus 2 minus, and then -1 cubed is -1, so minus -1/3 plus 2, which would give us 1/3 minus 2 is -5/3 minus, and then -1/3 plus 2 is 5/3. And as you can see, we get a negative number, which doesn't make any sense, because how can you have negative areas? Well, the thing to realize here is that if the curve is if the area we're trying to find is completely under the x-axis, we have to negate the whole thing, because the integral will give a negative number, but the area is not. So if it's completely below the x-axis, you take the absolute value of the answer you get, which would give you 10/3. So actually, like from the get-go, you'd put this in the absolute value sign, and then you do all that, and then you get this, which would give you this. So the real area is 10/3 for the curve f of x equals x squared minus 2. Let's say though, let's erase this first. Okay, let's say you had a curve like that. So we don't even need to know its area precisely. Let's just say we're trying to find the area where it's bound to the x-axis. Well, what you do is you integrate the function, then you find the 3 points where it contacts the x-axis. So let's say this is x equals -3, x equals 0, and x equals +3. Then you'd split the curve into 2 parts. This would be, let me change color. This would be part A, this would be part B. So part A's area would be the integral of f of x with the domain 3, 0. That's like the boundary. And then you just find this area on its own, right? Part B would be equal to the absolute value, because we're dealing with an area completely below the x-axis, of 0, -3, f of x. And then after that, you'd add up the 2 areas. So the whole area would be that. And in this way, we can get a good approximation of the area. So that would be how we'd evaluate it. All right, let's go to some practice problems where we can put our learning to the test. So let's take this first practice problem. So it's asking us to first compute x cubed minus x, the integral where it's bounded by 2 and -2, x equals 2 and x equals -2. Well, so what we do is first integrate x cubed minus x dx, which gives us, oh, sorry, by the way, guys, whenever I miss dx, just remember to add it. I'm in a hurry, I kind of forget to add it, but you should always put it in. That gives us 1 over 4 x power 4 minus, and then that's half x squared. Okay, and now we just have to compute it, which means we do 1 over 4, then we put the higher bound in, minus 1 over 2, higher bound in, minus, and then we put the lower bound in. Oops, not 2. And I think it's important to realize that before we even go further, that all of these powers, wait, let me put that in a different color. All these powers are even. That means the number inside is going to be an even number as well. Now these values are literally the same if you put the absolute value. 2 and negative 2 are the same number if you absolute value both of them. So when they're raised to an even power, they're going to yield the exact same result, even if they're not absolute valued. So I think already we can tell that the answer, without even having to compute this, is going to be 0. Because this is going to be the same as this. I think this is a good question to start with, because it shows us that there is some part of the area that's underneath the curve, which is why we're getting an area that's 0. This curve doesn't actually have an area of 0 when it's bound to the x-axis. So it's quite telling that we have to do something more. So considering they haven't drawn the graph for us, what we have to do if we want to find the total area is find the parts where it contacts the x-axis. So let's set x cubed minus x to 0. And then we can factor x out to get x squared minus 1. X squared minus 1 is the difference of two squares, which gives us x plus 1, x minus 1 is equal to 0. So the three solutions of x are 0, well, let me put them in order, -1, 0, 1. So if we were to draw it out, it would look probably something like, oops. So we have x equals 0, x equals 1, -1, sorry, and x equals 1. Now the next thing we have to do is try and find, is it positive between each of these domains or negative? That way you can kind of sketch the curve and get an idea of what we're working with. Well, let's substitute a number in between -1 and 0. Let's substitute -½ Let's just put that into the thing. I'm going to use my calculator because it's quite annoying to do this mentally. So let's put -½ into the equation of the function. -½ to the power of 3 plus half, because the two negatives cancel out. That gives us a positive 3 over 8, which means it's going to look something, well, we can already tell since this is how cubics look. It's going to look something like that. And you can even check this by taking a number in between 0 and 1, like half. Half cubed gives you 1 over 8 minus half, that gives you -3 over 8. So it's going to be a negative part in between 0 and 1. So the area we are working with are these two parts, which are the same area because they both yielded the same value except in absolute value, except only when it's absolute value. Like they gave a negative number of one part. And it's also similar because over here, we really got we really got 0 because the two parts were equal. So we can kind of tell that's equal parts. Now it's time to break it up into A and B. A, B. So the area of A is going to be the absolute value because it's under the x-axis of, and then you have x equals 1 to 0. And then the function is x cubed minus 3, well, not 3x, sorry. Sorry, it's 1 over 4. No. X cubed minus x. My bad, sorry. Dx, which is equal to, and then it's equal to the integral. Oh, well, not integral. We can write this bound out. Oops, sorry about that. We can write this out as like that. That's how you show you're going to substitute 1 is the higher bound, 0 is the lower bound, which is equal to 1 over 4, and then 1 to the power 4 is just 1, so it's going to be 1 over 4, minus 1 over 2, because 1 squared is just 1. And then we don't have to subtract it from anything, because if you put 0 into anything, it becomes 0. So this is just all you have to do, which gives you, and the absolute value, don't forget, negative a half, but it's in the absolute value, so it gives us a half. Now we know basically that b is going to be half as well, but we should just do it to check. We can't just cut corners. So that we wouldn't do the absolute value here because it's above the x-axis of 0, negative 1, x cubed minus x dx, which is equal to 1 over 4 x to the power 4 minus 1 over 2 x squared, which is equal to 1 over 4, sorry, it's 0 minus 1, which would give us, well, it would give us negative 0 minus, because 0 times anything is 0, and it's a higher bound. And then we'd put this in brackets, 1 over 4 minus a half, when you substitute all the values in, which gives you 0 minus half, which also gives us half, which is what we expected. And to find the area, then we add the two areas up, which gives us half plus half equals 1 unit squared. Oops, that's a bad squared. So that's our answer. We can take a look at one more problem before we wrap up this video. Okay, so we're going to start with question 1. If you would like to follow along, then sure, but if you want to do it yourself, you can, and pause the video and then check your work afterwards. Now we're going to start it as a group. First thing we have to do, since we're given this, is find the x-intercepts, as we're not sure like how the curve looks and if there's anything below the x-axis yet. So let's equate this to 0. So that becomes this. We bring everything to the other side so that we don't have a negative coefficient of x squared. Gives us this, which is a lot easier to work with, which gives us x plus 1, sorry, x minus 1, wrong sign, and x plus 2 is equal to 0. So our x values are negative 2 and 1, but we can already x out one of the x values, x equals negative 2, and select 1, because x equals negative 2 does not fall in between these boundaries. Only x equals 1 does. Now, if we were to draw a diagram of the whole curve, we could see that here it's negative 2, here it's 1. So the curve would look something like this. But this part to the left of the x-axis doesn't matter. Let me just highlight what doesn't matter. That does not matter. What matters is this part. So let me put in red what matters. This part here, bounded here, is what matters. But also, if we imagine an imaginary line going to x equals 2, then this part also matters because it wants us to find the entire thing. So let's first do part 1, because we kind of answered part 2 to an extent. Part 1, we just need to find the integral. So if we do this, we just put the higher bound in, so negative 2 squared minus 2 plus 2 minus, and then we put the lower bound in, which just gives 2, because everything else gets cancelled out when you put 0 in, which gives us negative 4, and then minus 2 plus 2 is just 0, minus 2, which gives us negative 6, which is definitely not correct for part 2 because areas can't be negative. So for part 1, our answer is negative 6. Now moving on to part 2, we can kind of use the diagram we've established to help us. Let's obviously label our parts A and B because they're parts that are above and parts that are below. So part A, we don't need to do the absolute value. We can just find this. And if we evaluate what the integral of negative x squared minus x plus 2 is, we get negative a third x cubed minus half x squared plus 2x. So if we evaluate this part, it gives us negative a third. And then 1 cubed is just 1, so it's going to be a third. Negative a half plus 2 minus. And then there's nothing to minus because if you put 0 in, the whole thing becomes 0. The whole thing becomes 0 because anything times 0 is 0. And this gives us negative third minus half is, let me just use my calculator. It's negative 5 over 6, and if you add 2, it gives you 7 over 6. So that's part A's area. So now for part B's area, we would have to use the absolute value because it falls below the x-axis as shown here. So that would be the integral of 1 negative x squared minus x plus 2 dx, which is equal to, and then the absolute value, and then we have the integral right over here. We can reference negative 1 over 3, then we substitute 2 in, 2 cubed, minus 1 over 2, 2 squared, plus 2 times 2, minus, and then in brackets, negative 1 over 3 minus half plus 2. Because if you substitute 1 in, the x just really becomes irrelevant. Which becomes, in the absolute value, so 2 cubed is 8, so it becomes negative 8 over 3. And then 2 squared is 4, minus 4 over 2, plus 4. And 4 over 2 we know is just 2. And then that's subtracted from, well, it's added to 1 over 3, because 2 negatives make a positive, plus half minus 2, which is equal to, and then we can just use our calculator to input the whole thing. Firstly, what we can do is cross these out, because they make 0. So we're only left with negative 8 over 3, plus 1 over 3, plus 1 over 2, which gives us negative 11 over 6. But it's in brackets, no absolute value, so it'll become 11 over 6. Now we just add the two areas up. So 11 over 6 plus 7 over 6 gives us 18 over 6, which is just equal to 3. So the answer is 3 units squared. The area over here, this area of A and B, is equal to 3 units squared. And that's our final answer. So thank you guys so much for watching this video. I think that's enough practice in this area. In the next one, I'll try and cover things like what if it's between two curves and what if it's bound by the y-axis, etc. And if you have any questions whatsoever, do let me know in the comment section. But otherwise, I'll see you in the next one.